10, no, 5. No, 1 to 11. Okay, let's start here. In exercises 1 to 5, the diagonals of a rhombus ABCD intersect at E. Given that the measure of angle EAD, this one, 67, and CE is 5 and DE is 12, find the indicated measure. Take note for rhombus. What are the properties of rhombus? Yes, diagonals. Let me write here. What happened to diagonals of rhombus? Diagonals are perpendicular. Diagonals, what else? Diagonals bisect. Do they bisect each other? Yes, the diagonals. Diagonals bisect vertex angles. So for rhombus, diagonals are perpendicular, bisect each other, and bisect vertex angles. So it's given here that this angle EAD 67 degrees. Therefore, the measure of angle AED, this one here, is 90 degrees. Because diagonals, yes, I'm writing here in purple. Okay, now can you see that? Alright. Okay, properties of rhombus: perpendicular, bisect each other, bisect vertex angles, they're diagonals. So therefore, angle AED here is equal to 90 degrees. The reason is the diagonals of a rhombus are perpendicular and they form 90 degrees. Next is measure of angle ADE. Where is ADE? This one. What do you think is the measure of angle ADE? Take note that diagonal AE, this one, AE, bisects DAB, this one, DAB. Yeah, and minus another angle. So it should be 180 minus 67 minus 90. There's one. What is that? 180 minus 90 minus 67. What is that? Okay, so this is 23 degrees. The 67 here is only EAD. If it bisects, then this is also 67, right? 90 is 23. Okay. Then the next one, angle BAE. This one. So it's also 67 degrees. Then side AE. AE, diagonals bisect each other. Therefore, AE is equal to CE. Yes, that's also equal to 5. Then BE. BE should be equal to DE, which is 12. So BE is also 12. Okay, for number 6 and 7. In exercises 6 and 7, find the lengths of the diagonals of rectangle JKLM. What are the properties of the diagonals of rectangle? Diagonals of a rectangle are congruent. So let's say this is, we don't have a drawing on this, right? Drawing. J, okay, JKLM. So it says JL. Okay, let's say this is the diagonal. JL and then KM. Yeah. So we just have to equate them. JL equals KM. What do you mean by sector? Yeah, but it doesn't matter because we are not asked for that one. We're only asked for the lengths. Find the lengths of the diagonals of a rectangle. And the diagonals of a rectangle are congruent or equal. And we're given here the diagonals JL and KM. So we can just equate them. They're equal. Then we can solve for X. Once we solve for X, then we can solve for JL and KM. So let's solve for X. You want to try this? 3x plus 4 equals 4x minus 1. Can you solve for X? 5? Okay, that's correct. So X here is equal to 5. Now you can solve for a JL. So you just plug in 5. 3 times 5 plus 4. That is 15 plus 4. 19. And then the other one, KM, is 4. Oh, they're equal. So 4 times 5 minus 1, of course, it's 19. Then for number 7, let me delete this. Number 7. So that is JKLM, the same. We're given JL and KM, so we just equate them. They're equal. So JL equals KM. Oh. Sorry. 2x minus 6 equals equals 3/2 x plus 1. But can you solve for x here? Yeah, I think some fiber like wanted to my nose. Yeah, you get the LCD. So you 2x minus 3/2 x equals 1 plus 6. You get the LCD. LCD is 2. 2 divided by 1 is 2 times 2x is 4x. Then minus 2 divided by 2 is 1, 3x. It's x over 2. And then you multiply both sides by 2. And you get x equals 14. Then you can plug in 14 here. Did you get the same value for x? And 2 times 14 minus x. Then 3/2 times 14 plus 1. Is this 22? 28, 22. So JL is and KM, they're equal to 22. No questions on this? Okay, so let's move on to exercises 8 and 9. Decide whether quadrilateral W XYZ is a rectangle, a rhombus, or a square. Give all names that apply. So you must know what a rectangles, rhombuses, and squares are. So rectangle, they don't have only 2 sides are equal. Square, all sides are equal. How about rhombus? Okay. So this is what we're going to do. We're not given the quadrilateral here, but we're given the vertices. Yeah? These are the vertices, W, X, Y, Z. So let's solve for the, what's this? The distance. Yeah, so it doesn't even tell us that W, X, Y, Z are vertices. So let's just assume these are vertices. So we find the distance between W, X, X, Y, Y, Z, W, Z. Okay, do you know how to solve for the distance? Distance formula. X2 minus X1 squared plus Y2 minus Y1. Distance from X to Y, distance from Y to Z, and distance from W, Z. We'll see. These are the coordinate, what's this? Coordinate pairs, ordered pairs. So this is X, Y, X, Y, X, Y, X, Y. The first numbers are the X values. So you find a distance from W to X. W to X, you just plug in here. X sub 2. So let's say X sub 2 is 3. So 3 minus 3, 0. 3 minus 3 plus squared plus Y sub 2. Negative 2 minus 1 squared. So this is 0 plus negative 4 squared, and negative 3 squared is 9. So this is 3. So the distance from W to X is 3. Then XY. Can you see my writings on the board? From point X to Y. So you have to do this one by one. From point X to Y, that is negative 5 minus 3 squared plus negative 2 minus negative 2 is plus 2 squared. So negative 5 minus 3 is negative 8. Negative 8 squared is 64. So square root of 64, that is 8. So the distance from X to Y is 8. Then YZ. Okay, YZ, negative 5 minus negative 5 is plus 5, 0. Then 1 plus 2 squared, this is square root of 9. So this is 3. So distance here 3. Then distance from W to Z. W to Z is 3 minus negative 5 is 3 plus 5 squared plus 1 minus 1 squared. So this is square root of 64, which is 8. So distance here 8. Yeah. Notice here that only two sides are equal, opposite sides are equal. So that means this one is a rectangle. Equal. Can you see my drawing? This one. Yeah. You take a screenshot of this. And then for number 9, the same thing. For number 9, the same thing for number 9. Let me do it here on the side. Okay. Distance from W to X. Square root of 1 minus 4 squared plus 4 minus 1 squared. So this is negative 3 squared, 9. plus 9, so square root of 18. Then distance from x to y, square root of negative 2 plus 1, negative 2 minus 1 squared, plus 1 minus 4 squared. This is square root of 9 plus 9 square root of 18. Then distance from, okay, let me draw that one, the other triangle here at the bottom, because there's no more space. Just put it here. Let's say this is the other triangle, the other quadrilateral. So this is W, X, Y, Z. Okay. Distance from WX, XY, YZ. YZ, that is 1 plus 2 squared, negative 2 minus 1 squared. So this is 9 plus 9 equals square root of 18. Seems like the sides are equal here. WZ, okay, equals square root of 4 minus 1, now 4 minus 1 squared, plus 1 plus 2 squared. So this is square root of 9 plus 9, square root of 18. So all the sides are equal. And this can be a square. How about rhombus? Are the sides for are the sides equal for rhombus? Okay. Now rhombus, rhombus and squares, they have all of the four sides are equal, but for the rhombus, the opposite sides are parallel. Yeah. So if to prove this one, to prove whether it's a rhombus or a rectangle or a square, because here, okay, we have to, this is obviously a rectangle in number 8. For number 9, it can be a square or a rhombus. So you calculate the distance, you solve for the distance of the, what's this, diagonals. Or maybe we don't need to, because it doesn't even, like, you know, no instruction here. So just answer their square or maybe a rhombus. Because you calculated the sides and they're all equal. Then for number 10, use the figure to write a 2-column proof. PSUR is a rectangle. PQ is congruent to TU. QS, prove that QS equals RT. Okay. It says rectangle, so that means the opposite sides are congruent. So that means this one is congruent to this, and this side is congruent to this side. Right? And diagonals in this one, since they are congruent, so that means this one is also congruent. Because we form two triangles here, this triangle and this one. Okay. So you write the given, this one, given, and then what else? Since opposite sides of rectangles are congruent, so PS is congruent to RU. Then your reason will be opposite sides of rectangles are congruent. And they form two triangles here, right? We already knew that this side is equal to the other side and this one is congruent to the other side. Then we can conclude that QS is congruent to RT by SSS congruence. No, there's no angle here. There's no angle given, so you cannot say SAS. We're only given sides. Number 11. All sides are congruent and all angles are right angles. Determine whether the quadrilateral is a rectangle. Explain your reasoning. All sides are right. It's not a rectangle. Yeah? Yeah. So it can be a rhombus. It can be a rhombus because all sides are... no. Maybe no, because all sides are congruent and the sides of the rectangle are not congruent. Rhombus, no, because it says all angles are congruent. So take a look at here, the given. All sides are congruent, all angles are right angles. For rectangle, not all sides are congruent. For rhombus, all sides are congruent, but the angles are not right angles. Only the square and the rectangle. They are supplementary. So no, angles are not, all angles are not right angles. They're supplementary. No, all sides of a rectangle are not congruent. Only the opposite. Determine whether the quadrilateral, yes, this one. The answer is square. Because all sides are congruent and all angles are it's a no. Why do you say yes? Yeah, but the square is not a rectangle. A is rectangle. It says, see, rectangle. Then D, AEB. Where is AEB? This one. Find AEB. Square. Diagonals of a square are perpendicular. Because we've already determined that it is a square, right? Diagonals are perpendicular. So they form 90 degrees. So that means this is 90. Then AD. Diagonal bisects this one. This is 90 degrees. So this is 45 degrees. Can you go to the next page? Okay, practice B. Oh no, it's the same thing. Decide whether the quadrilateral... Yeah, you need to solve for the distance again. Okay, this one. Let's say this is, for the first one, this is quadrilateral. JKL. LM. So you find the distance between 2 points. Distance from JK, square root of, what's this? 7 minus 3 is 4 squared, plus 6 minus 5 is 1 squared. So this is 16 plus 1 square root of 17. Then distance from KL, point K to L. That is 6 minus 7, negative 1 squared, plus 2 minus 6, negative 4 squared. So that is 16, okay, square root of 17. Then distance from L to M, that is square root of, make sure you know how to do this, negative 4 squared plus negative 1 squared. Huh? I already wrote directly because there's no space. So I wrote x sub 2 minus x sub 1, that is 4, plus y sub 2 minus y sub 1, that is 1. Then distance from J to M, that is 3 minus 2, 1 squared, 5 minus 1, 4 squared. So this is 17. So all of the sides are equal, square root of 17 for the first one. All the sides are equal, so this can be a square or a rhombus. Then for the next one, number 2, J, K, L, M, the same thing. You get the distance from J to K, that is square root of negative 4 plus 1, so negative 3 squared, plus negative 1 minus 5, negative 6 squared. So this is square root of 9 plus 6 times 6, 36 plus 9, 45. Okay, distance from K to L. This is how you do this. 4 squared plus negative 4 squared, 16 plus 16, 32. Then KL, LM, square root of 3 squared, then plus 6 squared, so this is square root of 45. Then JM. Are you going to have an exam on this? Yeah, good luck if you're given like this, because you have to solve. Okay, I think I made a mistake. KL. 1 minus 1, negative 1 minus 5 is negative 6. Then a negative 6. Then 5 minus 2 is 4. So 45. Now 5 minus 5 minus 2 is 3. So all of the sides are equal. So it can also be rhombus or square. Questions 3 to 7. Diagonals of a rhombus ABCD intersect at M, given that measure of angle MAB is 53. Find the indicated measure. So diagonals of a rhombus are perpendicular. They bisect angles, bisect each other. So AMD, this one. So this is 90 degrees. They are perpendicular. Then ADM, this one. Diagonals bisect at angle A, so that means this is 53. So you just subtract 180 minus 53 minus 90. So that is 37 degrees. Then ACD, this one, diagonal bisects angle C, and angle C is, okay, this one is 37 and this is 90, so that means this is also 53 degrees. Then DM, diagonals of a rhombus bisect each other, so DM is also 16. Then AC is 24 because this is also 12, so this is 12 plus 12, 24. You understand? Okay. For number 8, find the point of intersection of the diagonals of rhombus with vertices. Oh, what if you're given that rhombus? That is your rhombus, given the vertices. Diagonals bisect each other, so we find the midpoint of any diagonal. So let's say this is negative 1, 2, 3, 4, 5, 8, 1, 6. This is the diagonal of the rhombus. It says we find the point of intersection of the diagonal. So this point of intersection is here. Yeah, that means it is the midpoint of the length of the diagonal. So let's try this one from this point to this point. The midpoint of that is 1 plus 3 over 2, 6 plus 4 over 2. So this is 4 over 2. That's the midpoint formula. So this is 2, 5. So the point of intersection is 2, 5. So this is 2, 5. Okay, we're number 9. Use the figure to write a 2-column proof. WXYZ is a parallelogram, then angle XWY is congruent to XYW. So it's an isosceles. That means the sides are also equal. And it says WXYZ is a rhombus. So that means the sides are equal. Okay. So you write the given, this one, for your 2-column proof. Then, okay, you can write here XY is congruent to XW. Your what's this? Reason would be congruent angles